Hi everyone, today in Integrated Math 1, we're going to go over Chapter 6, Lesson 6. Here are the objectives. Make sure you write them down in your notes. Alright, so let's get straight into this. Example 6, we want to solve the system of inequalities. So that means I came back for a little bit by graphing. We have y is less than 3x plus 1, and y is greater than or equal to negative 2x plus 3. So this is my first equation, and this is my second equation. And when we're graphing, we want to make sure it's in the correct form. It needs to be in the form of y equals mx plus b. So in this case, we have our y. It's not equals, but it's our inequality, so that's okay. M, which is our slope, x is good, plus b. And remember, b is your y-intercept, which is your starting point. So let me make that note really quick. M, slope, B, y-intercept, and I'm going to say start. Okay, so for my first equation over here, I know that my slope is, well, let's put that over 1, 3 over 1. We have a rise of 3 and a run of 1. And then I know that my B, my y-intercept, is plus 1. So in that case, because it's our y-intercept, it's going to be 0, 1. That's our point to start. Then I look at the equation, at the inequality sign. It says it's less than. So remember, because it's less than, you're going to use less ink, which means I'm going to have a dashed line. You're not putting it, you don't have that little extra line, so now it's going to be dashed, so spaces between them. All these little details are very important. So if I'm looking here, I also know that my line is not I'm going to have to test some points. So I'm going to choose my point 0, 0. And you'll see that's a perfect point when I go back to my graph. So 0, 0. Every single time you see x and y, it's going to be 0. We're just testing out our points. So 0, which is less than 3 times 0, plus 1. Well, that says 0 is less than 1. That is a true statement. And because of that, you're going to shade on 0, 0, on the side of 0, 0. Shade 0, 0 side. Now let's look at our second equation. Well, our slope is negative 2 over 1. We have a rise of negative 2 and a run of 1. Then our b, in this case, is 3. So we know our point is 0, 3. And because of this extra line here, we know it's going to be a solid line. So no spaces, no dashes. And I know from here, because I know I'm starting at 0, 3, I know I can use a point of 0, 0, because that's not where my line's going to be. So I could test this one out again, which is perfect for us. So I'm going to have every single time I see x and y, they're both 0. So 0 is greater than or equal to negative 2 times 0 plus 3. 0 is greater than or equal to 3. Well, obviously that's not true. That is definitely a false statement. And because of that, we're going to shade on opposite side of 0, 0. So let's actually look at this with the graph though. So remember we have our equation, the y is equal to 3x plus 1. So that's shown here with our graph. Notice here it's a dash line, which is what we said, and I did pick 0, 0. Remember, when I pick 0, 0, it's a true statement. That's why this whole side over here is shaded in red. Then if we go back to our second equation, where y is greater than or equal to negative 2x plus 3, it's shown here with our graph. It's a solid line, and remember we also picked the point 0, 0, and we said it was not true for this equation, so we had to shade the opposite side, which is this one here. So this should look very familiar, except now you're using two equations. Before we only did it with one. I'm putting two equations of lines on the same graph. And what I want to do is just to find out where they overlap. In this case, it's where you see the colors overlapping. So in that case, it's right here, this whole portion over here. And that's your solution. And there we go.